Good morning, good afternoon, and good evening, everyone. This is Ayo Academy. You are welcome to my channel. And today we are going to look into a question under nodal analysis. This is DET 201 applied electricity. And today we want to be dealing with um, a question under nodal analysis. So we are given a question here, and the question says that find the current through 2 ohm, 6 ohms, and 7 ohm resistors. And we are given this circuit. So this circuit now, I'm going to redraw it this side. So let me be fast and just put them here. So let me be fast. 3 amps and 3 2 sorry 2 ohms, 2 ohms. Here we have 6 ohms, 6 ohms. So we put it there. Here we have 7 ohms. Here we have 12 amps. So that is that. So there are some steps that are required in solving questions using nodal analysis, and one of it is that we should assign voltage to essential nodes. So what I mean by essential node, look at the word essential node. Essential node. Okay, essential node is a point in a circuit which is connecting two or more components. Three or more components. Three or more. So when we have a point in a circuit connecting three or more, that is the minimum of three. So connecting three or more points in a circuit, we call it essential node. So this place is a essential node. So if you look at this side, you see that this side is having a line. Look at this line here. We have another line here, and we have another line here. So making it three lines. You get what I'm saying now? We have three lines. And if you also look at this side, you see that the line is coming from here, and the line is coming here coming from here. So as well. So then that makes it essential node. So I will assign voltage here. I will call it V1. I will assign voltage here. I will call it V2. So I will put a voltage here, 0 0 volt. I put it there. So actually it can be also, you can put it here if you're calculating. As soon as I'm calculating the potential difference between these two, so this one will be here. So I'm calculating from here to here also, or from here to here, how we what I put it there. So that is it. And the next one is okay. Actually, this point is a first node, and this is a second node. So if you look at this, you see that is this current. This is a current source, so it's facing upward. So we make another one here facing upward. So this will be parallel to each other, facing upward also. So I will call this one high one. Look at this side. This one is facing downward. I make another one parallel to it, facing the same direction. I will call it high 2. You get what I'm saying? High 2. So to make a clockwise direction, so you can see this one is as if it's something like this. So I'll make another one here. So I will call it what? High 3. I call it high 3. Now, so what am I going to do? We are dealing with nodal analysis, so I'm going to use KCL. Using KCL, Kirchhoff voltage law, KCL, using KCL. So for the node 1, look at this. We have 1 2, that is I2, this is I1, I2, this is I3. Okay, this one is common between them. What does I mean by common is that if you are counting, maybe you are having, we have A, B, C. Look at A, B, C. This is A. I can start from, if I'm counting from the front, I will have this one is 1 2 3. If I'm counting from the back, I will have 1 2 3. You know, this one still lie between. You get what I'm saying now? It's still 2. Maybe I'll start counting from the front or from the back. It's still what? 2. So therefore, this one has to be the middle of both. So what will I do now? Look at this current and look at this one. They are facing the same direction. I need to add it together. So to give me this one. If you also look at this one, both this one are facing that one. I will add it together. It must give me equals to this one. Is that taken on? How? What do I mean by that? Okay, so that will not cause confusion. If you look at this one, you see that it's going upward. And if you're looking at this one going upward, though, if you trace this one, it's moving to the node here. If you're also tracing this one, it's moving to the node. Is that clear now? And according to the Kirchhoff current law, he said that the amount of current entering a node is the same thing as the amount of current leaving that node. The algebraic sum of current entering a node is equal to the algebraic sum of current leaving that node. So if you look at this one, they are going to this point, this one is also going to this point, and this one is leaving. So you can see. So those one that are going, so we have it as node 1. Now we have 3 amperes, and we have this one I1 to give me I3. Actually, this is equation 1 for node 2. For node 2, so what I have in node 2, I have that this current is coming. Look at this arrow facing downward. Here is coming like this, and this one is also leaving, going like this. So we had it together. But this one is now going where the two currents are leaving. So I need to have those currents together, and it will give me the current that is going where the two currents are leaving. So they are leaving there, but this one is going there. So now we have 12 plus I2 is equals to I3. So that is equation 2. Now we've obeyed what KCL says. Now after this, the next step is to use Ohm's law, using Ohm's law. Ohm's law. What does Ohm's law state? Ohm's law states that V is equals to RI, or you call it IR. Anyone? It's still the same thing. Either you call it IR or RI, same. 2 times 3, 3 times 2 is still 6. So that is it. So I want to make high the square root formula because I'm dealing with KCL. I'll make high the square root formula. So I'll bring this one to here through division. Therefore, it will now occur as I is equals to V. R is coming under over R. So what will I do for this one? So this is I here. So you can call this one R1 because anything here is 1. So I call this one R2 and this one I call it R3. So that is it. So here I have my current I1. So my current, look at current here, current equals to V over R. So I1 is the current at this point. So V is the potential difference between these two places. So I have 0 minus V1. So I have 0 minus V1. So what is the resistor under it? Can you see? It's 2. So I put it there. So what will I do if I simplify? I will have minus V1 over 2. Is that taken? Look at the second one. So I2, look at this one. I have it's as if it's moving. Look at this arrow coming from here, moving downward. That's V2 minus 0. As V2 minus 0 over, look at the resistor. Look at, I'm working on the resistor. Resistor is 7 here. So if I have it, how we have I2 V2 over 7. The next one is the current going from this side going to that side. So we have I3, that is V1 minus V2, and that gives me under 6. So that is it. It's still correct, so I don't need to simplify anything. So this is just direct. So since I've obtained all these ones, then I'm going to bring them back into this KCL. I'm going to put them inside the KCL back. So I have the value of my high one to be minus V1 over 2, that of our high 2 to be V2 over 7, this one, and we have I3 gives me V1 minus V2 over 6. So I have all this one. So I just need to bring them back into the KCL. So what will I do? So I have 3 from here, from the equation 1 here, I have 3 plus I1. My I1 is minus V1 over 2. Okay, is equals to I3 is actually V1 minus V2 over 6. So I have 3. This is plus here and this is minus here. So it will give me minus, because we know mathematically that plus times minus is minus. So V1 over 2 is equals to V1 minus V2 over 6. Now look at this 6 and look at this 2 and look at this 6. What is the LCM of the 2? The 3, the 2 and the 6. What's the LCM? Okay, you may not know, but let me just show you. This is 2 and this is 6. So what is 2? 2 is the same thing as 2. 6 is the same thing as 2 times 3. So I will carry this one. They can give me a single 2. But I'm still having 3 here. So 2 times this 3 give me 6. So that is the LCM. So that is the LCM. So I'll use that 6 to multiply 2. So I will use this 6. 6 times 3 is actually 18. So 18 minus 6 times V1. So it's as if I'm putting 6 here. So because if I multiply this one, I give me 6. That's 6 divided by 2 to give me 3V1. Is that taken? If I use this 6 to multiply this, to give me 6 into, you understand? So 6 divided by 6 is 1. So I'll just say it's equals to V1 minus V2. Is that taken? Very good. So I'll collect the light and I bring everything inside. So if I bring everything inside, what will remain outside? It will be 0. So 18 minus 3V1 minus V1, because if this one come inside, it will become negative. So that's why it's negative here. So if I take this one that is negative inside, it should become positive. So V2 is equal to 0. So if you look at this one, you see this is negative 3 and this is negative 1. You are owing fair money 3 naira and you are owing all cash 1 naira. If you add it together, it gives you a debt of 4 naira. So 18 minus 4 V1 plus V2 is equals to 0. That is equation 3, because I've written equation 1 and 2 here. So I'm done using this one. So I'm substituting what I got in Ohm's law into KCL. So let me do to this next one. So I'm having equation 2 here. So I have 12, right? 12 plus, what is I2? My I2 is V2 over 7. So V2 over 7. Okay, it's equals to. So I3, what is I3? I3 is V1. I'm talking about this one. I've used equation 1. I've substituted it inside, and I'm substituting it now into equation 2. So I have V2 over 6. So let me just put it like this. It's actually so necessary for me to put this bracket. So sorry, it's a mistake, but it's good. So this is 7 and this is 6. So what is the LCM for 6 and 7? So let's just multiply the two together. So if you multiply it together using your calculator or using your brain or using multiplication table, 7 times 6 is 42. So 42 now times 12. Let me bring my calculator here. So I have 42 times 12. That give me 504. Give me 504. 504. Okay, that is 504. Okay, and if I use this 42 times this one, it as if 42 will be here. So 42 divided by 7, that give me 6V2. So if I use this 42 also to multiply this side, thank God I've already put bracket, so it's nice. So 42, if I put 42, so 42 divided by 6, that is 7. So 7 in bracket V1 minus V2. So what will I do now? I'll use 504 plus 6V2. I'll use this 7 to multiply through V1. This one times this one minus V2. Is that taken? I'll take everything inside. 504 plus 6V2 minus 7V1 plus 7V2 is equals to 0. This one will come inside and become negative. This one become positive inside when it comes inside. So we leave 0 outside. So V 504 plus 6. Oh, this is 6 v2. This is v2 also. So we can add it together. So it will give us 13 v2. Then minus 7 v1, it will be 0. So that's actually equation 4. So the next thing now is to do the reasonable thing that we need to do. So if you look here, we have 18 minus v. We are dealing with equation 3 and 4 now. So v is equals to 0, and here is actually equation 3, and here 504, sorry, 504 plus 13 v2 minus 7 v1 is actually 0. So that equation 4. But the problem I'm having now is this. I just want to rearrange it. I want this one to be, I want v1 to come first. So we have minus v1 plus v2, right? Plus v2 and then plus 18. You know, this 18 does not have minus, so it should be plus. It should be 0. It's still the same thing, nothing changed. So let me rearrange this one. Minus 7 v1. So this one will follow 13 v2. Understand? And then plus 504 is equals to 0. Section 4. So that is that about that. So the next thing here is that let me use matrices using matrices. So let me put them inside. So for the data whole, I will use this one. Understand? So this one will come first. This is minus 4 and minus 7. So for the delta 0, I will not, anything you are dealing with, you are going to remove it. This is v1, this is v2. So we are this one, this which is the coefficient. It's a constant, it's not a variable. So it should be theta 0. So we are going to remove it, and we are going to deal with what these two. This is minus 4. But this v2, what is the coefficient? Yeah? How many v2 we have in here? What do you say? You say 1, right? So the coefficient is 1. So we have minus 4 and 1. So minus 4, 1. Here we have 7. Minus 7, sorry, not 7. Here we have 13. So what do we do here? So we're going to use this 4 to multiply 13. So 4 times, minus 4 times 13, minus 4 times 13. So gives you minus 52. So I will use this one to multiply this one. So minus 7 times this one. So I will say minus. So this one times this one, it will now minus 7 times 1. So this minus is always, when you multiply this one, you minus it with what the multiple of this one. So minus 4 times 13, it will give you minus 52. So you now put to minus. So minus 7 times 1, so it will give you minus 7. So minus 52. Look at minus here and look at minus here. So it will become plus. So 72. So 7 rather. So I will have minus 52 plus 7. So it give me minus 45. Is that taking? So look at delta 1 also. So this is delta 1. Anything that is 1, I will remove it. So I will remove it. So I will use this one. The coefficient of this one is 1, as I said earlier. So it's 1, 1, and this one is 13. This one is 18. This one is 504. So I will use it. So I will use this one to multiply this one together. So we have 504. That is 1 times 504 is 504. Minus this one times this one. Let me just use my calculator. So we have 18 times 13. So we have 234. 234. So let me use calculator again. 504 minus 234 to give me 270. Give me 270. So let me also say delta 2 also. Delta 2 now, I'm not using this one. I'm only using this one and this one because I'm talking about delta 2. So anything that is 2 here, I will not use it. So I have minus 4, minus 7, 18, and 504. So what will I do here? I will use so minus 4 times 504. So give me 2016 minus, so I'm having here, I will have minus 7, which is here, times 18 times 18 here. I will have, so give me minus 2016 plus, because this is minus and this is minus, will give us plus 126. So 1 minus 2016 plus, sorry, plus 126. So it give us minus 1,890. So that was it gave me. So according to what we do now, we have v1 should be under theta 1. So we have minus that's how we normally have it. You must put minus here. So theta 2, so 1 over delta 0. So we have v1 over delta 1 is actually 270, is equals to minus delta 2 v2 over what delta 2 is what, is equals to 1 over delta theta 0 is minus 45. So actually this negative we cancel this negative. So for me to get, this is minus 45. So for me to get this one, so you can make this one equals to this one and do cross multiply. But instead of you wasting that energy, so you just say 270 divided by 45 minus 45. So you just use, let's say this v. So if you cross multiply, if you make this one equals to this and you cross multiply, you will get the answer as if I'm saying 270 divided by 40 minus 45. So let's use calculator here. So as if you are using this one to divide this one. What about v2 also? V2 will also be like this. It will also be like 1. Now you are using it to divide this one again. You get. So that is it. So let's do that now. So we have 270 divided by minus 45. So it gives me minus 6. This one also, let me just change the values. It gives me 1,890. So it gives me minus 142. Minus 142. So what will I do now? What should I do? This is what I'm going to do. So so for me here, I have I1. So for me to get the current now, I have my I1 to be minus V1 over 2. So what is V1? V1 is minus. So already have minus here. So minus into, that's minus 6 divided by 2. So this minus and this one will become plus. So that's 6 over 2. And that's give me 3 hands. So out of 2 now, so what do I have there? I have V2 over 7. So what will I have there? So I have V2 is minus 42 divided by 7, and that gives me what gives me minus 6. So what about I3? I3 is giving me this. Look at I3. I3 is V1 minus V2 over 6. So V1 is minus 6 minus, look at 42 here. So this is minus here, and this 42 is minus 42. So over 6. So if I say minus 6, if minus and minus will give us plus 42 over 6. So let's say I have minus 6 plus 42. That will give me 36. So 36 divided by 6. That gives me what? 6 amps. So what will I do now? So therefore, the current that flows now, I1 will be 3 amps. I2 will be minus 6 amps. And I3 will be 6 amps. 6 amps. So this is the current. This is the final answer. My name is Ayo Academy. Ayo Josiah Yomide, and you are welcome to my channel once again. And my phone number, my WhatsApp number, it's 0706311 8290. Please do share the video, comment, like, shout me up on WhatsApp if you have any question. Do good by commenting, share, like, and subscribe to my channel. Follow me. God bless you. Have a good day.